Hello, everyone. Welcome to Global Hack Week. We're just at the end of day 2, I believe. Welcome back to part 2 of Intro to Data Structures and Algorithms using Python. Um, I'm glad to be back. If any of y'all were here for part 1, you saw that we had just a few technical difficulties, but fingers crossed, all that is resolved now, so we can go ahead full steam ahead. How's everyone's Global Hack Week been going so far? Have you gone to any interesting sessions since the last time that we spoke? I'm curious to see what y'all have been enjoying and how your week has been going. And while I wait for those responses to roll in, kind of as some housekeeping / an introduction to today's session, if you have not checked in already, I posted the link in the Discord chat, but I'll put it up here on screen again. The check-in link for today's session is bit.ly/GHW-DSA-Pi2. I'll put that up on screen again. It's highlighted, but I'll put it in the chat as well. So this is the check-in link for today. Be sure to check in. I'm glad to see that people are doing good and that they're enjoying their Global Hack Weeks so far. Crackers and Cheese says that there's too many good streams to watch, so they're getting behind. Love to hear that, and that's the great thing about Global Hack Week is everything is recorded, so it'll be uploaded shortly after to our Twitch and YouTube channels, so you can catch up on anything that you may have missed due to sleeping, other responsibilities, work, school, cooking, etc. All right. So as like a brief introduction, if you missed our first session, DSA in Python stands for Data Structures and Algorithms. Data Structures and Algorithms is a super valuable skill for engineers, both if you're looking for a job right now, this is the core functionality of what technical interviews are, but also once you actually get that job, data structures and algorithms make you a much more efficient engineer. Once you actually land that job, I've found myself that when I've been interview prepping, whether that be in university or otherwise, and I'm doing LeetCode problems more consistently or just like reviewing the different algorithms and the core functionalities of data structures, that I'm able to find solutions and more efficient solutions when I'm coding, whether that be in my university classes or at my full-time job. For those of you that don't know, data structures is defined as a way that is a defined way to organize, store, and manipulate data in the memory of a program. These are things like strings, lists / arrays, dictionaries, linked list. There's many more data structures, but those are some basic ones, some ones that we'll be going over today and in part 3 of the stream. And an algorithm is a step-by-step programmatic rule for solving a problem. So these are different approaches to the data structures and algorithms problems that we'll be solving. These are common strategies for how to solve them. And I hope that y'all were able to check in into today's Global Hack Week stream. Make sure you're doing that for all streams as they boost your points and you're able to be eligible for things like swag or different achievements throughout Global Hack Week. As far as who I am, my name is Gabriella. I'm a coach here at Major League Hacking. Otherwise, I'm also a full-time software engineer. And kind of as like a little shout out, the link at the bottom, that is the short link for today's slides, but don't worry about quickly copying those down. I will be sharing those at the end of the stream. And if we run into any more technical difficulties today, knock on wood, that isn't the case. But if that happens, I'll send them out in the Discord as well. All right. So kind of want to check in on everyone today and see where everyone's experience lies with data structures and algorithms. So I have 2 questions. Just answer them one at a time, please. So first of all, do y'all know Python? You can answer yes, no, or a little bit. If you're a little bit rusty, you can let me know that as well. But just pop that in the chat so I can kind of see where everyone is at and how much I need to explain the problems as we're going through them today. I talked about this a little bit in part 1, but I know that every stream has a little bit different viewership, so I want to make sure that each session I have a good understanding of what hackers are tuning in. Okay, so we have a few people who, yes, a little bit rusty. Okay, that's good to see that most people are a little bit familiar with Python. So we can kind of dive straight into explaining the algorithms and actually solving the problems. And then my second question for the experience check is I'm curious if y'all have done LeetCode problems or taken a HackerRank assessment before. And for those of you who are new to data structures and algorithms, new to technical interviewing, LeetCode is a platform where you're able to practice data structures and algorithms problems on your own. It has test cases and you're able to do them kind of like asynchronously on your own to practice. HackerRank has some things you can do for practice on your own, but more largely kind of serves as a technical assessment tool when you're interviewing for an engineering position, or if you're in a university course. Sometimes professors will put technical assessments on HackerRanks, on HackerRank, not HackerRanks, my bad. Okay, and then so if you've done one of those, you can write that. If you've done neither, that's completely okay. It's beginner's week after all. And if you've done both, that's excellent. I'm just kind of curious to see how much you'll need an explanation of the actual platform. And that way I'm not skipping over relevant information and everyone understands what's going on. It looks like we have someone who knows Python, who has done LeetCode and HackerRank before. Quackers and Cheese prefers Code Wars. I remember this from last session. You preferred Code Wars. There's also many similar platforms that serve similar purposes to LeetCode and HackerRank. These are pretty common ones, but there's also other ones that are useful as well. I participated in various competitive platforms, but not really good in any of those. I'm curious if you mean if you're not good at competitive programming or if you just haven't used LeetCode or HackerRank before. And for this question, how do I participate in a HackerRank? You will receive like a technical assessment if you're interviewing for a position. Otherwise, you can just go to HackerRank and they'll have practice problems and kind of prep work you can do on that. Okay, and then a beginner in LeetCode. Awesome. So looks like we are mostly familiar with Python in today's audience, but we have kind of a mix between if we've actually done any LeetCode or HackerRank problems before. So that's a great place to be. All right. So kind of as a review from part one, what we did in part one, if you were not here, we had some string, array, and dictionary data structures overviews. I walked everyone through what they were, and we did a single practice problem before we ran into some technical difficulties, and we had to end the stream early, unfortunately. So some of the initial material I had planned on doing in part one, we'll go over to part two. Hopefully we're able to make up for lost time and finish everything that was initially planned by the end of part three. Part three will be on Wednesday. But if that isn't the case, then I'll have everything in the GitHub repository as well as the slides that will be shared. So you're able to catch up on that lost material on your own, and I'll provide resources as well. But needless to say, now it's time to get into part two. So we're going to be working on more algorithms and arrays specifically, a little bit of dictionary and string work as well, but most of what we'll be focusing on today is arrays. So we're going to continue to talk about strings, arrays, dictionaries as data structures, but we're also going to dive into two pointers and the sliding window algorithm for like specific like approaches to problems. And we're going to do some practice problems related to that. If we have time, we might go, as well cover binary search. That would be a reach if we're really cruising along and moving through these problems quickly. And as always, if you have any questions throughout the entire stream, feel free to drop them in the chat. Since I'll be live coding the solutions to these problems. I might not always see them immediately, but I'll be sure to go back and answer them as as I can. Okay, so let's get started. And then here are our practice problems. If you were here for part 1, we went through the contains duplicate problem. That was the only one we were able to finish before my computer decided to shut off and not turn back on. But we have some additional ones for strings, and then a whole list of problems in the dictionaries and arrays data structures. I'll be moving on to some algorithmic explanations once we get to problems that make sense for that. But I'm going to go over the contains duplicate problem that we worked through together last time, just as a quick overview if you weren't here in the last session. This will just be a very quick explanation versus walking through the entire thing like last time, and then we'll move on to our next problem. Okay, so for those of you who were not here, oh, it looks like this did not save because my computer was messed up. But essentially for our contains duplicate problem last time, we used a dictionary to find the count of the array. So we looped through the length of the arrays to see if they contained, oh no, this is why it's not here. We didn't do contains duplicate. I got out of order because the problems were slightly out of order. We'll be working on contains duplicate in just a second. What we did work on was valid anagram. My apologies. A little bit out of sorts as we ran into issues last time, so trying to adjust my slides. Okay, apologies. What we did work on last time was valid anagram. This problem, we're essentially trying to see if two strings are an anagram. If you're unfamiliar with what an anagram is, it's essentially when you can use all of the letters in one string and rearrange them to make a new string. Usually it means a word. In this case, we're just checking to see if it's the string to string versus if it's a valid word. So what I did for this was we checked to see if the length was equal, because if the length is not equal, it's not a valid anagram. We created 2 dictionaries to house the counts of the characters of both strings, one for the T string and one for the S string. We created dictionaries to hold the counts, and then we looped through the length of S because the length of S will be equal to the length of T. So we only need to have one loop going through everything. And then what we did was we essentially counted the length, or we counted the frequency of each of the characters in the string. And then after the for loop was done executing and we had the counts of all the characters in both strings, we just returned if T dictionary was equal to S dictionary to see if the counts of all the characters were the same. I remember when we went through this on Friday night that this had relatively good time complexity, but not that good of space complexity, which we're going to cover in part 3. But essentially, the time and space complexity are how quickly your program runs and how much memory it's taking up when you're solving that problem. This problem was a little bit more memory heavy because of the dictionaries. There are some more efficient ways to solve it. But that was our first go around. It's a passing solution. It's a little bit closer to brute force than an optimal solution, but it does solve the problem nonetheless. Okay, so that's what we did in part 1. Now we're going to move on to part 2. This is another easy problem. That doesn't necessarily have a specific algorithm tied to it, but just kind of some more basic array understanding. And as you can see from Friday evening, we have some basic array and string, just like some basic print statements and variable declaration. This is from when I was explaining what a string and array were for our viewers on Friday. I'm going to skip that explanation for today in part 2. If you'd like to go back, you can watch the recording from Friday. But we're just going to dive straight into this contains duplicate problem. So kind of like I did on Friday night, I'm going to go through an explanation of this problem. We're going to make sure we understand it properly. And then after that, I'll type out some step-by-step some steps for how to solve it before we actually dive into coding. So our explanation for today is that given an integer with an array nums, we're going to return true if any value appears at least twice in the array, and we're going to return false if every element is distinct. So what we're essentially given in this problem is an array of numbers, and what we need to do is we need to return true if multiple of same integer, and return false otherwise. So as far as how I think would make the most sense to solve this problem is that we need to start I guess base case for this is going to be false. If the entirety of our logic executes, we'll return false. But as we go through and we see any duplicates, that's when we're going to return true if we're seeing the same integer at least twice in an array. There are a few different ways to solve this. The first and kind of like more elementary or intro level approach is going to be with dictionaries like we did last time. There's, I guess, a few ways. Dictionaries is a pretty basic approach. There's, I guess, like 3 I'm thinking of right now, but we'll get started before I get too in depth with the different approaches before we actually start coding. So for this, initially what we want to do is create a dictionary, and this is going to essentially house I guess there are, I think, 2 ways that we could go about this for the intro level / brute force approach. We could create a dictionary. We could also create an array. And what we essentially want to do is see, I guess, house the integers we've already seen. And then secondary, we're going to loop through our nums array. And if our current integer is in our variable, we're going to return true, because if it's already been seen, it will have been appended into our array or dictionary. And if that's the case, we don't need to see anything else. We don't need to append more to a count or append more to an already seen array. So we can just return true. And then otherwise, else, we're just going to append / add at int key our current integer, and then if the entire for loop executes, we will return false. This makes pretty good sense to me. If anyone has any questions about this, you can feel free to drop them in the chat. It looks like we have one. Can we use for loop to check if n is in a list, and then print a Boolean value? Yes, this is, I guess, like similar to kind of the approach I'd had listed out. I had dictionary or array. Dictionary, I guess, was like what was most top of mind, as that's what we used in the most recent problem. But I think an array would make more sense for this initial / brute force approach. Since we don't need to have the count, we're just going to see if it exists already in this list, then we're going to print true. So I'm going to X out dictionary, as you're right. That doesn't necessarily make much sense. Okay. Create an array. And we are going to append, not add. Okay. And then I'm going to start coding. So I'm going to create an array, and it's just going to be called scene. It'll be an empty for now. And then for I in nums, if I in scene, return true. Otherwise, we're going to append I into scene, and then we'll return false. And as I explained in the last session, there's 2 buttons up here, or I guess 3. This is a debugger button that's only for premium users. I don't have LeetCode Premium, so we're going to ignore that for now. There's a run button and a submit button. When you click run, it runs a few sample test cases to see kind of preliminary how your code is running. This is to kind of see like a few sample test cases if your code will run. This is similar to what you'll create when you're actually creating test cases on your own. It's more likely or common for you to create maybe 1 or like 3 to maybe 10 cases off the top of your head when you're doing test-driven development, like as an actual engineer. When you're doing actual testing or kind of like more quality assurance type of testing, before something goes into production, you'll do something more similar to the submit button, where it runs anywhere between like 40 to 200 test cases. Those are all like very useful and like test it with a bunch of different scenarios, but it is like a higher bar to pass. So this is thinking of it as like more of a local bar to pass before passing the overall bar. And also with the test cases, I talked about this last time, but you can add your own in this preliminary check. I'm going to add in for this test case just an empty array to see how that handles it. As that's kind of like an edge case before you submit it to see if it's passing all of the test cases. Okay. Oh, I see. This was in the constraints. I should have read the constraints more carefully. Well, it is an edge case. It's been taken care of in the constraints. So I'll just have 1 and this. Okay. All 4 accepted. Now we're going to submit it to the higher bar. Okay, and as we can see here, our time limit has been exceeded because this is a brute force approach. It's passing the majority of the cases, but not all of the cases. So we want to make sure that our problem is passing all of the cases. So in this case, what we're going to do is alter our approach. And I'm going to resist the urge to do more of a hack slash very, I guess, like one-liner solution and see if we can do maybe a middle of the road approach. So the reason right here, the time limit is being exceeded, partially due to the for loop, but also due to the if, I, and scene. So what this is doing that's going to cause it to exceed the time limit if we have a very large array is it's searching through the scene array to see if our particular index is in that array. And so it's not only looping through all of nums one time. For every time we go through nums, it's also going to be looping through / searching and scene. So we need to essentially cut it down. So we're only only iterating through our nums array once, and we're not also going to be searching through a secondary list / array. So in this case, I'm going to go up here and edit our steps. I can kind of talk through this and why I think this new solution will be better and more time efficient. So essentially what I want to do here is that instead of creating an array to house the ints that we've already seen, I think that what might be more time efficient is to sort our current array of nums, because as you can see here, sometimes they come in numeric order, sometimes they don't. So if my thought process here is that if we sort them, so in this case it would be 1, 1, 2, 3, we can check to see if the last, or I guess the index before our current index is equal to what we're seeing, then we return true, rather than searching through the entire list every time. And that way, we'll be sorting the list one time versus searching through the list every single time we loop through our nums array. So I'm going to comment this out, and I'm going to, let's see, nums is equal to nums.sort. This might not be the right syntax right off the bat, just because sometimes when you're working with multiple languages, you kind of forget the syntax. Okay. Okay. So we're no longer going to do initial step 1. What we're going to do instead is we're going to sort our nums array, and when we're going to still loop through our nums array, but instead of searching for our current int in the new variable, what we're going to do is we're going to see if current integer is equal to previous integer, will return true. Otherwise, we're just going to continue. This also means that we need to start at index 1 rather than starting at index 0, like the default is for our for loop. Okay. Yeah, okay. So for I and nums, and also just for the sake of like clarity / explanation, I'll comment out everything so that when it's getting uploaded to GitHub at the end of the stream, we have all the attempts that were made at different problems. I'll make it a little bit more clear when it's being uploaded to GitHub, but just for the sake of now, it'll be commented out. And then after this, we're going to see, okay, so for I and num, let's see. So what this essentially is going to do is start at 1 and then go to the end of the length of nums. And then we're going to begin checking if actually, I'm going to do this in a different way. For I, x, and enumerate nums. If I is equal to 0, we're just going to continue. Otherwise, what we're going to do is if x is equal to nums at I, like 1 before that, we'll return true. Otherwise, we're just going to continue. And then if it executes successfully, we'll return false. Let's see how this executes for our first few test cases. Oh, oops. Okay, in this case, I think that we don't need to reassign it, and that's the issue. Okay, so it's accepting our first few test cases. Let's see if it passes a higher bar. Okay, it looks like this is passing the higher bar. This still feels like a somewhat brute force solution. As you can see here, it has really good memory, beating 99.81% of other solutions, but our runtime is pretty low. So I'm going to show you kind of like what I would do now for a solution. I would say that this is a perfectly acceptable solution for someone who's like more of a beginner in Python. But this is the solution I'm going to show you next is a more efficient solution. So kind of as notes, first attempt did not pass. And then here we have our second attempt did pass. And for this, this is somewhat of a hacky solution, but I think that like a pretty easy way to do this is to have really good time complexity is to get rid of the for loop altogether. We don't need to sort anything altogether. For those of you who are new to Python or new to coding in general, a list, like one of the things that sets that apart from a different data structure called a set is that you can have multiples of something, whereas in a set, you can only have a single occurrence of each value. So if we're able to essentially compare the initial nums list to a set conversion of our list, that will tell us if there are duplicates, because if we convert our list to a set and it's not the exact same, the values aren't the same, then it's not going to be equal because we know that there are duplicate values. But if they are equal, then we know that there aren't any duplicate values. So I'm gonna just comment all of this out. This was our first and second attempts. We'll just have return nums equal to set of nums. We might need to make it a little bit more complex than this, but I think this is all we need for now. Nope. Okay. So let me check something really quick. Okay, I see. Okay, so I oversimplified this, but we're on the right track. So essentially what we need to do, instead of just returning if they're equal to each other, since they are different data types, they're not going to return the exact same, like they're not going to be returned the exact same as a set and a list, have a little bit different ways of structuring data. We essentially just want to see if the lengths are the same, because if a set and the list have the same length, that means there aren't any duplicates. But if we convert it to a set and the length is shorter, that means there are duplicates. Okay, we're going to run this one more time. Nope. Okay, what am I doing wrong? Okay. Wait, no. Okay. I see. Instead of just having them be set equal to each other, it should be not equal to each other. Yes. Okay. Because we want it to be true if a value is appearing at least more than once, and if the length of the initial list and the set are the same, that means there are no duplicates. And that would return true, but we want it to return true if there are duplicates. So it's a little bit of a reverse of that. So it'll just be return if they're not equal to each other. So if they are not equal to each other, that means there is a duplicate. Returning true, like our direction state. And then otherwise, it's going to return false if they are equal to each other. So we'll try it one more time. Beautiful. Now let's see if it passes up higher bar. Awesome. So we have much better runtime here. Last time we attempted, this was a runtime of like beating 10%. Our memory is a little bit less efficient. Our first go around, I believe that our memory was beating a higher percentage. We can see it in our submissions. Yes. Yeah, so our memory was 19.2 millibytes versus now it's 26. So because our runtime is so significantly better, that's something that we're going to accept. And I think it's good to have that trade-off. All right. So that contains duplicates. Do we have any questions? I'm going to check the chat now. Oh, it looks like Quackers and Cheese came up with this optimal solution as I was talking through things on the other screen. Way to go, Quackers and Cheese. It was not that crazy. It was the optimal solution. So way to go. All right. And to be entirely honest, I'm not sure what sorting algorithm is behind .sort. I'm honestly curious, so I'm going to look that up now. It's not the most algorithm time efficient, but as you can see, like it was time efficient enough to pass like the lead code time like efficiency test. So it wasn't the most optimal solution, but it was somewhat okay. It looks like it uses a more advanced hybrid sorting algorithm called power sort since Python 3.11. And then the previous version used a Tim sort algorithm. Okay. So the more you know. That's something I did not know before today. So I'm also learning on these streams as well. Okay. In JavaScript for sorting algorithm is like comparing two values, and based on negative and positive, we put the value before the other. Oh, interesting. I did not know that offhand. I've worked with JavaScript a little bit, but I work with Python much more frequently, and I'm much better at Python just because I work with it a lot more often. Okay. Okay, so we've solved our first problem of the stream. Way to go, y'all. So now we've solved contains duplicate and valid anagram. So next we're going to go on to sum. Let's see, I'm going to refresh this. Okay. And kind of as a brief explanation, this is the last one I think we're going to solve. Yeah, the last one we'll solve before I dive into the algorithms. Algorithm explanation for today. This is another array problem. Look, kind of as a heads up, given an array of integers called nums and an integer of target, we're going to return the indices of two numbers that add up to our target integer. And as far as the assumptions it's giving us, we're going to assume that each input would have exactly one solution, and we can't use the same element twice. So for example, if our target integer was 4, we can't use 2 at index 0 twice. And we can return the answer in any order. So if we find, for this case, 2, 7 add up to 9, we can return it as 0, 1, but we can also return it as 1, 0 if that's the order way that we find them in. Okay, so now let's dive into this. So what we receive, so we're given a nums list and a target integer. What we need to do, we need to find the two integers in nums that equal target. And then we need to return the indices of those integers. That's an important call out. We do not want to return 2, 7. We want to return the indices of the two integers that add up to our target. All right. So for our, as far as like what we're going to do for our solution, I think that for our first attempt, at least, I'm going to do something with, I think we'll do dictionaries as well. So we're going to create a dictionary to hold key value pairs, and these key value pairs are going to essentially be, it's going to be the number, and then, I guess, no, what we're going to do is, in the case of, like, we see 2, what we're going to do is we're going to put in essentially the other number that we need. I don't know if I'm going to make this stupidly complicated, but this is what I'm going to go with for right now. And then if it doesn't work, then we can face that then. So it's going to hold a key value pair of target minus I. And then the value of that is going to be the actual index of I, but that doesn't make any sense. So we're just going to set the current, it's going to be the current integer. So target minus current integer. And then we're going to set that equal to index of current integer. So how this like looks in practice is going to be, we get to the first one and it's going to be, we're going to get 9 minus 2. So we'll append 7, 0 here. So if we, how this will work in practice is that if we see our current value in the dictionary, then we're going to find the other index to return. Now that I'm explaining this out loud, this does sound stupidly complicated. So I'm going to do it in the reverse, which probably makes more sense. Thank you for bearing with me as I think through all of this. So instead of it just being target minus current index, I think what we're going to do is have it hold the current index and then the index of current, or the index of current integer. So that'll be 2, 0. So we create the dictionary. This is the kind of stuff it's going to be holding. Now that I've talked through that, and again, anything I'm saying it doesn't make sense, drop a question in the chat. I want to make sure that everything makes sense and that y'all are able to learn from this. Okay, and then for step 2, once we've created that dictionary to hold all these values, what we're going to do is we're going to loop through our nums array. So loop through nums, and then we're going to ask if target minus current integer in our dictionary, we're going to return index, I guess we'll do current integer index, and then we'll return dictionary at, and then we'll just have the difference that we're finding there. Otherwise, what we're going to do is we're going to append this into our dictionary. Okay, and then because we are assuming that each input would have exactly one solution, we don't need to move through our problem with, so like I completely lost my train of thought, sorry. So we're gonna move, because we have the assumption that our input has exactly one solution, we don't need to prepare for the edge case that it wouldn't have a solution. We need to return like something like 0 or like undefined. So I think this is good to go. I'm gonna get started. So we're gonna have our indices dictionary, and then we're going to loop through our nums array. So I'm going to do a for I x and enumerate nums again. And for those of you who are new to Python, new to coding in general, what the difference is between this and a normal for loop is that with this for loop, we're getting both the index and the actual item in the list. So here we have 2, 7, 11, 15. So as we loop through this, I is going to be equal to the index. So we'll get 0, 2, 1, 7, etc. And that makes it a little bit easier to append things into our dictionary. So we're later able to access the indices, which we'll need because we're returning the indices rather than the actual numbers. Okay, so and then I'm going to have a difference, just so this makes the code a little bit cleaner, easier to read. We're going to have a difference will be equal to target minus x if difference is in indices. We're going to return I, and then indices at difference. Otherwise, like we said earlier, we'll go to our difference at the key of our value, or at the key of our number and on the key of our value. That's needlessly confusing. So difference at the key of our integer will be set equal to the indices. And then I think we're good to go based off of the instructions I had initially typed out. We will run this and see if it passes our preliminary test. Let's see what error we're going to hear. Int object does not support. Oh, so I did difference instead of indices. It really is always the silly stuff when you make mistakes, or usually in my case, it's the silly stuff. Okay, so it's passing the preliminary test. Let's see if it passes the big tests. It passes. Awesome. So this is beating 100% of other submitted solutions for time complexity, and it's beating 77% of other solutions for memory. I would say this is an excellent solution. I don't know if it's the optimal solution for this one. We might be able to get the memory a little bit better, but I think in this case, we're doing pretty well. I'm going to check and see if there's any questions. Oh, it looks like we had a little bit of a conversation going on. It looks like someone said to solve this problem, they used a 2-pointer solution. That's also a valid solution. I don't know what the time and space complexity will be, different to what we did. We'll be talking about 2-pointers in just a second. So great approach. Okay. Quackers and cheese. So they were rubber duck with cheese. I love that. Yeah. And as far as what I did, it's a hash map-ish solution for this problem. Just because a lot of times, like at least when I'm leak coding, I will go back to problems and try to solve them from memory, or just like by thinking through it, which is how you do them in interviews. So we don't also always know what algorithm is matched to what approach I'm taking. And since I didn't talk through any hash map specific algorithms, I'm not entirely sure like which algorithm would match up to it, but generally, yes. And it looks like we have some back and forth on principles first thinking. Yes. I love to see the support for everyone. Yes, also like if you are feeling confused and not entirely sure how to even approach these problems, that's totally normal. That's how I felt and still do feel with some more hard problems on LeetCode. You get better with them with time, like anything, in practice, especially with these problems. If you're not, at least me personally, some people might just be able to like store this in their mind. If I'm not regularly doing problems or at least kind of like reading over them, I forget some of this. If at work, I'm not spending a lot of time actually coding in Python, I'm doing more product based thinking or other things, you kind of begin to get a little bit rusty. And especially like when you're first starting, it's even more difficult because you haven't built like that like that type of problem solving and like those just like the baseline knowledge it doesn't exist in your brain yet, but you'll like slowly begin to like build those connections and like that knowledge base as you do more problems. And if you don't know how to approach them in the beginning, what I did when I was first starting and what I do now when I see a problem where I don't even know the algorithm that should be used to solve it and I have no other idea of how to even try a brute force solution, is I'll just go watch a tutorial video or I'll read through potential solution online. If there's no tutorial video, I highly recommend a tutorial video over just reading through the solution. Again, all this depends on like your learning style, but I find with the tutorial videos, because it's taking minimum like 10 to like 10 minutes to half an hour to explain it, you'll be able to understand more of like the background algorithm and data structure to the solution. And then after like you've been walked through the solution and how to do the problem, come back and try and solve it on your own the next day, a few days later, to kind of see if it's sticking. And then after repetition, you'll get better at it. I kind of think of it similar to how you learn math. Some people might just be able to like slowly figure it out by tinkering around with it, but the majority of us need to have an explanation of how to actually solve the problems. You can't like know how to do long division or know how to do derivatives if you haven't been shown how to do them before. And these are somewhat similar, even though Python is like a very similar, like it's the language that's the closest to English. You still need to know how to, like what data structures to use and what algorithms to use. So you can't do something you've never learned how to do before. So just essentially like read through potential solutions, read through or watch tutorial videos, and of course like write out your ideas and write out like what it's asking for so you understand the problem, like what it's asking for, even if you don't know what to do. But don't like be beating yourself up if you're not able to like initially when seeing a problem know what to do. It takes time and practice. Even for this one I can show you, yes, the solution was submitted and I'm able to walk y'all through this in like maybe 15 minutes, but you can see that I've done this many times. I got this wrong as recently as April, but I had done it many, many times before. And as you don't do problems, like for a little while, you like lose the skill set or forget things. So, and as you can see, when I had initially done them, like way back in 2021, when I was first learning how to do data structures and algorithms, I got the wrong answer over and over and over and over again. And then I finally got the right answer after, let's see, 13 submissions. So it takes time. And also, if you don't do it for a little bit, when I was getting back into data structures and algorithms to relearn for interviewing in 2023, as you can see, I was getting runtime errors, even though I had successfully solved it 2 years before. So you forget things. And when you're first trying, it takes lots of practice. So definitely, if this is a little confusing, we've all been there before, and with practice, it'll get better. All right. Okay. So that is the solution for two-sum and a little bit of an explanation of how to go about learning data structures and algorithms. So I'm going to give everyone a 1-minute break so I can grab a water. Really my throat starts to dry up a little bit just from talking for a while. So I'll be back in 1 minute, little intermission. And then if you have any questions, of course, feel free to drop them in the chat in the meantime, but I'll be back in 1 minute. See you all then. All right. Hello, everyone. I'm back. Brief intermission over. I have my water. It's in a coffee cup. I don't know if you can see it. But yeah. Okay. So we've done 2 problems, which is great. Everyone's doing amazing. I love all the questions. And I love that y'all are answering other hackers/viewers questions when I'm walking through the problems. I love to see that collaboration. So now we're going to come back to the slides. And now that we've talked about some strings, some arrays, the basic data structures, I'm going to talk through a few different types of algorithms. So like one of y'all said earlier, 2 pointers is a very common algorithm and is a potential way to solve the problem that we just did. So 2 pointers essentially are an algorithm to reduce the amount of time you're spent looping through an array. So rather than going through and seeing 2, 5, 3, 1, 9, you can cut that in half by having 2 pointers, one usually at the beginning and one usually at the end. And this allows you the ability to check values at 2 points throughout the array. Typically, this starts at the beginning and end, like I said, but in theory and on occasion with different algorithms, you can have pointers at different points throughout the array for more specific types of problems. But essentially how this will execute is you'll have a for loop, and after checking the pointers for their values against the needed conditions in the loop, you will increment one of them up or one down. So essentially what this is doing is reducing the amount of time spent to go through all of them, because you're able to cut down on the time spent looking at each individual item, and you're able to look at 2 items at once versus each individual item. And in sorted list in particular, this is very helpful because you're able to see the lowest and the highest. In this case, this isn't the case. Like in this particular problem, that's not the case, or example, I guess. But if, for example, you're trying to see just where is, or if the value 5 is in this list and you want it to be a more efficient searching algorithm than just one initial searching statement, you could have a loop go through and check, is 5 at index of pointer 1? No. And it like is index or is 5 at this index? It makes more sense when this is sorted, but essentially, no, it is not at index 0 and 5 is greater than 2. You'll need to increment upwards. so that you can check to see if the next one is 5. And then if you're looking for a lower number than the end, you will want to decrement down for pointer 2. All right. And then I'm also going to walk through an explanation of another algorithm, and then we can kind of dive into some practice problems. So we can just kind of stick with LeetCode for the rest of the session. So another one is going to be a sliding window as an algorithm. So rather than iterating over the same elements over and over, similarly to 2 pointers, this is just going to save time. So what you're going to do is you're going to set like a subarray and then shift it throughout the array. So it's going to start at index 1. So in this case, we have a subarray of 3 items. So it's initially going to be 4, 9, 2. In this lovely illustration, you can see it's being pushed throughout the array. But if whatever condition you're looking for isn't there, you're going to shift it upwards by dropping the first index in your subarray and then adding on a new index. So in this case, you started with 492. You're going to drop the 4 if whatever condition you're looking for is not met, and then you're going to add on -1, and so on and so forth. As you can see, on the third iteration, you drop the 9 at the first index of your subarray, and then you add on 0 until the last index of your subarray is also the last index of your actual array. All right, do we have any questions about those algorithms so far? Okay, I'll give y'all a few minutes and I'm going to go back to our practice problems and kind of divide them up by the type of algorithm that they are, just to make it a little bit easier for us to solve them. Okay. So valid palindrome is going to be a 2-pointer solution. I think we can also, I don't know, you can put in the sound off in the comments. Does anyone here want to solve two-sum in a 2-pointer approach to solve like another problem, like solving the same problem in another solution, or do we want to only do 2-pointer solutions for new problems to kind of keep them separate in our head? Or would it be valuable to see how we can do the same problem at a different approach? You can sound off in the comments as I'm sorting through and getting our next problems up. Okay, and then we have 2sum2, input array is sorted. That'll be another 2-pointer solution. I think that, okay, let me know what y'all think, but I'm thinking that we can just stick to 2 pointers and new problems. Okay, we have a question. How long should the subarray be in the sliding window protocol? Typically it's between, like it's a odd number and it's at least 2 less than what the length of the actual array is, but it varies based on what you're actually looking for in your condition. That was an answer to this question. Okay. All right, so we don't have a consensus on if we want to do new problem or the same problem. I'm going to just go on to new problems, and then if we have extra time towards the end of the stream, we can go back to 2sum and do that with a new approach, just so we have a little bit more exposure to new problems. And then if we have more time, we can go back. Okay, so we're going to work with is valid palindrome, or also known as valid palindrome. I'm going to talk through this, and then we can talk about our 2-pointer solution. Okay, so let's see what it's actually asking. Okay. And I'm going to get rid of, or I'm going to just group these two together. finished problems. I don't even know if you can see my actual like URL tabs or not, but I'm just grouping them so it's a little bit easier for me to look through everything. Okay. So a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. And then this is just kind of explaining what a palindrome is, because that's what we're looking for in this problem. But given a string S, we're going to return true if it is a palindrome, and then false if it's not a palindrome. Okay, so this is a little bit more complicated of what it's looking for than anagrams, but still relatively straightforward. So we're given a string, and what we need to do, check if palindrome, return true, false, depending if on results. Okay, and then what we need to actually find for a palindrome, we need to convert all letters to lowercase, and we need to remove all non-alphanumeric characters. So only numbers and letters in our string. And then lastly, forwards is equal to backwards of our string. Okay, so this is what we need to do in kind of like plain English. Now I'm going to talk through what we're going to do with code. So the first thing we want to do is convert all of our letters or everything in the string to lowercase. So I think we'll just do that by assigning s to s.lower. We might need to change this depending on if lower automatically saves in s. I always forget if it does or not. And another thing that I'm going to do is I'm going to remove all of the white space because white space is not an alphanumeric character, and it's a little bit more difficult to remove otherwise. So I'm just going to do that with a simple replace method. So I'm going to replace all white space with no space. And then after that, what we're going to do is begin our two-pointer method. So how you typically go about creating a two-pointer is you're going to create a left pointer and a right pointer. And in these pointers, what you're going to set them equal to is the index where they're pointing to. Like we said earlier, usually one is at the beginning and one is at the end of our list. So in this case, we're just going to have it be 0 and like the end of our list. I'll walk through the actual syntax for that later. And then after that, for a two-pointer method, how you go about it is just by looping through your specific list. But rather than having it be a normal list, it's going to be a while loop instead of a for loop. So the difference between a for loop and a while loop is a while loop executes while a condition is true, and a for loop will execute for the entirety of the length of a list. And this is kind of why a two-pointer solution is going to be a more optimal time complexity solution than like a for loop. And this is just because the two-pointer solution is going to execute only while left is less than right, rather than rather than looping through every individual item in that array. And the left and right pointers, so at 0 and the last item in our index, are going to change values so that this is executing faster than a normal for loop would. So we're going to create our while loop, while left is less than right. And then in our while loop, we need to actually have conditions to make sure that our left and right pointers are actually executing properly. So in this case, what we want to do is, now that we have converted all of our letters to lowercase and we've removed part of the non-alphanumeric characters, we need to check essentially to see if our other characters are alphanumeric, and we're going to do that using our left and right pointers. So I'm going to add a little checkbox here because we've done that. We've partially done this. So in our while loop, we're going to have two statements, and one is just going to be a basic if statement. We're going to have, I guess, kind of two if statements, if, elif, and we're going to check to see if our string at our left pointer is alphanumeric, and if our string at our right pointer is alphanumeric. And if that is the case, then we're going to increment or decrement. So basically, we want to check if string at left or right pointer is not alphanumeric. We're just going to increment or decrement by 1. And this is essentially going to skip any alphanumeric parts of our string. Oh, that's not what I would want to be shifting to. I want to stay on valid palindrome. I'm talking, and sometimes when I'm talking my hands, I begin to talk my mouse. So when we are incrementing or decrementing by 1, this allows us to skip it, because the main logic of our two-pointer solution here is we want to compare if our strings are the same. So here, a man, a plan, a canal, Panama is a palindrome. So what we want to do is, with our 2 pointers, we want to have our 1 pointer be here and 1 pointer be here, and we want to compare them. So if string at left pointer is equal to string at right pointer, we can continue, and if not, we're going to return false. But we can't have index, let's see when the first one would be. So here we get to our comma. This is going to be at what? Comma, and then like another random character, probably somewhere in Panama. That's not going to be true, but because our conditions of what a palindrome is do not include non-alphanumeric characters, we don't want that to be happening. So we're going to increment or decrement by 1 if it's not alphanumeric. And then if we have our string at left and string at right are equal, we're going to do both. We're going to increment up by 1 and decrement down by 1. And what this is essentially doing is similar to just a continue statement, but because we have a while loop rather than a for loop, we need to do decrementing or incrementing with our pointers in order to continue to move through our string. And then kind of like our last else is we're going to return false, because if we're getting that 1, they're alphanumeric, because this is checking to see if both of the characters are alphanumeric. So we've checked and they are alphanumeric. And then we're also checking to see, are they equal? So the last kind of catch-all is going to be if they are not equal and alphanumeric, we're just going to return false, because this means that we are getting something like this. So race a car, we're getting, let's see, C and E are going to be compared to each other, and those are not the same, so it's not a palindrome. Yeah, and then outside of our while loop, we're going to have a return true statement. So once while loop has executed fully, we will return false because this means, or return true, sorry. We're going to return true because we've executed the entire thing. The continue statements have completely executed for this entire string, and they've been found to be both alphanumeric and equal. So we have a palindrome. All right. Does anyone have any questions before I start to code? Okay. If not, then I'll get started. So what we're going to do is we're going to have S will be equal to S dot lower. And then also I'm going to replace all of the white space. So if there's a space, we're just going to replace that with no space just to get that out of the way, and we can properly execute our while loop for our two-pointer solution. So then we're going to have our left pointer. So our left pointer will be equal to 0, and our right pointer to be at the end of our string will be equal to the length of our S, but -1. Like we talked about in the first session, if you're new to Python, new to coding in general, everything is 0 indexed. So if we want to go to the end of something, we need to subtract 1 because the beginning is 0, like we talked about here. And then we can begin our while loop while left is less than right. We're going to begin our logic. So if string at left is alnum, going to double check the syntax. Yeah, okay, that's the right syntax for Python. This is a built-in function to check if a character is alphanumeric, and like we said earlier, those include letters and numbers. So if we get this and it's equal to false, so it's not alphanumeric, what we're going to do is we're going to increment our left up by 1. Okay, and we'll do this by inline incrementing. And then otherwise, if our right character is not alphanumeric, we're going to decrement by 1. And for our right side, we decrement to go lower because we want to start accessing items that are further into the string, and the opposite for the left, same reason we want to be accessing characters that are further into the string for our two-pointer solution. Okay, and now we can go to our last actual checking our elif statement. So first statement, second statement, third statement. So now we're going to be checking, hey, we know that both of these are alphanumeric, but are they equal? So if left string and right string are equal, we're going to increment both up by 1, which is the same as continue. And then if we go through all of this, they are alphanumeric, they're not equal, you just return false because it's not a palindrome. And then our while loop has executed, our two-pointer solution is done. If it completely runs without returning false, we know that it is in fact true. So that'll be the default case. All right, now I'm going to run this to see if it passes our base cases. Awesome, it's passing our base cases. Let's see if it passes the higher bar. Also, any questions about my explanation or this problem, drop in the chat. I'll be happy to explain. This is a great runtime. We're beating 90% of other submitted solutions. Our memory is pretty good, beating about 61%. Also, as kind of like a note, don't completely base how your run-in space and time complexity are based off of this. They can change based depending on like how recently something's been submitted, it's gotten better over the years. But in some cases, I used to submit something, and it would be failing, or I would submit a brute force solution, and then like change, like maybe comment out a character or be printing a different statement, submit the exact same solution, and it would have a different run in space or different runtime and different memory, just because of who was submitting at that time. Later, we'll talk about how to actually calculate your space and time complexity, but this gives you like a just brief glance into it. The not operator is available in Python. I just think that like when I had initially gone through and coded out this solution, it was not working with this particular method. This is a response to this question for someone who is a little bit new to Python. You were able to use it like I showed earlier when we were calculating, I don't remember which specific problem, but we were returning essentially, this was for the contains duplicate problem, where the most optimal solution that we did at the end was comparing the length of the list and the length of the set. We did use a not operator in that. I think that the first time I had attempted the solution, I tried the not operator instead of equal to false, and it was not giving me, it was giving me some error. We can try it here and see if it works this method. It looks like it's not going to work, but we'll try it and see if this works. And it might just be the placement as well. Okay, invalid syntax. Okay, in this case, I'll try it maybe before. Yeah, I think that it's just with this particular method. I'm sure that you could maybe find a way to have it be executing properly with the not operator, but it exists in Python. It just wasn't working with this particular method in a way that made sense quickly. So I just had equal to false because it was going to be faster and didn't really change the contents of the code. But good question, and good to be asking about the differences in syntax when you're learning a new one or learning a new language. Someone is asking, how do we go back and forth to check if it's a palindrome? I am not totally sure what you mean by this question. So you could add a little bit of clarity. So in this particular problem, we're checking to see if it's a valid palindrome, and we used a two-pointer solution by checking to see if the characters were equal. I don't know if you had more questions other than that. They might have just been when I was starting to explain the question. We could try it with a bracket to see if that works. Because I'm also curious myself. I want to be learning a little bit on these streams with y'all. So I'm curious to see these idiosyncrasies with the technology. It looks like LeetCode is yelling at me again. So I'm not thinking this is going to work, but we can try. I'm curious, so I'm just going to Google and see, okay, can you use the not operator in Python with list methods? Okay. Okay. So I have a, okay. We can try what you put in the chat, but off my quick Google search, I think that I found I guess this might be working. We'll see. Okay, it's also giving invalid syntax, but with a quick Google search, I found that Basically, this is an operand, so it should be only used with addition or like equals signs, but a way to make this a little bit more readable or like just a shorter code. According to my Google search, we can do if not rather than if equal to false, and this should work as well. So this would be the same thing as a not operator, but or a bang operator, whatever, and be a little bit more simplistic. Yeah, and it has like slower memory, but like I said earlier, this can change on LeetCode pretty quickly. Yeah, okay, the memory is basically the same. The runtime is quicker though, so thanks for saving me some runtime. Okay, and then from Gamers Programmer is a follow-up to the palindrome question. You understood what it did. It just looked a little bit complex at first. Totally understand that. A lot of these problems can be a little bit confusing at the beginning, so I'm glad you understand it now. All right, so we have about half an hour left. I want to make sure that I leave about 10 minutes at the end to leave time for questions and also going over some resources. But I think we have enough time for 2 sum 2. I'm going to move this over to my finished problems section. Oh, oops. And then we can look at 2 sum 2. So this is another problem that I solved with a 2-pointer solution. This is building on our initial iteration of 2-sum, the problem we did at the beginning. I'll just talk through this and then we can get started coding. So given a 1-indexed array of integers, it's called numbers, that is already sorted in non-decreasing order. They could have just said increasing, but okay, this was, I don't know, whatever. Sometimes LeetCode can describe questions a little bit interestingly, and this is a prime example, just increasing. I guess it could be the same number over and over again, and then it wouldn't be increasing, but semantics, whatever. Find 2 numbers that they add up to a target. Let these 2 numbers be numbers, okay, where, okay, let these 2 numbers be numbers at index 1 and numbers at index 2, where 1 is less than or equal to index 1, and index 1 is less than index 2, and index 2 is less than numbers.length. Okay, there is one solution. You can't use the same element twice, like there was in our initial problem solving. We can only use constant extra space, which means that we have to use a 2-pointer solution. As far as what constant extra space means, is that means that we can use an extra variable, but it can't be the same size or increasing at the same size as the target, if that makes sense. Well, we can talk about that a little bit more in part 3 when we talk about time and space complexity. Okay. And then we want to return the indices of the 2 numbers, index 1, index 2, added by 1 as an integer array that is a length of 2. Okay, so they explain this in a little bit overly complicated way, which I guess makes sense because this problem is medium. I think this is our first medium LeetCode problem in the series so far. So congrats if you made it this far. You're moving on up. And this is also a, this is the particular problem I was referencing in session 1 when I talked about how most programming, or most programming languages are indexed at 0. There might be a niche one that's indexed starting at 1. This is a particular problem that tripped me up, where I talked about how you had to add 1 at the end because it was one indexed solution. Okay, so Okay. I guess it says here that it's one indexed already. So I'm curious. What happens when I do this? If it just returns nothing. No. Okay, so it's not actually one indexed from the get-go. It's just theoretically one indexed. So we just add one at the end. Okay. That's a little silly, but I guess it's just there to make sure that you're properly reading everything, which I guess makes sense. A lot of people skim problems. This is getting besides the point. So essentially, what we are looking for is we're looking to do loop through the numbers array, find the indices of the two integers that equal target together. And then add one to both index and return in an array given numbers array sorted in increasing order. So we don't need to write non-decreasing, but okay. So here we have 2, 7, 11, 15, and we're going to be using a 2-pointer solution for this one. So okay, I think we're still going to do we're still going to start with our pointer at the beginning and the end. So similarly to last time, we're going to have we're going to create our pointers, and then what we need to do is we'll just create our while loop, and then the same as last time for most 2-pointer solutions, you're going to have it be while left is less than right. On very, very rare occasion, you'll sometimes have while left is less than or equal to right, but we we won't be using that today. I don't know why I brought that up. But anyways, after we create our while loop, then we need to go into our actual conditions. So I think to make for the sake of our code, I'm going to just sum the numbers from the get-go. So for this time, instead of having our sum be current index and last index, because we have 2 pointers, we can just sum the numbers at the index of both our pointers. So we're going to, inside of our loop, create a current sum value, and it's just going to be equal to let's see, nums at our left pointer, and then nums at our right pointer. And then we're going to check to see if our target is the same as current sum. In that case, we can just return our indices +1, of course, because this is a silly one index problem. And then the next thing we're going to do is we're going to add an elif statement to see if our current sum is greater than our target. And what this is going to do is add in our incrementing and decrementing logic. So our elif statement is just going to see if our target is greater than our current sum. Then we're going to want to decrement our right pointer down because we know that the given list is in increasing order. So if our target, we'll want to increase our left pointer in this case. But like I said, if our target is greater than our current sum, we're going to want to move our pointer up because it's in increasing order. And if our target is less than our current sum, then we're going to, we're going to want to decrement down. Okay, so if our target is greater, then we're going to want to increment our left up, increment left up, and then otherwise, we know that our target is not equal to our current sum. If this is the case, we know that our target is less than our current sum. Our target is less than our current sum. We're going to want to decrease because we want to move two numbers that are lower rather than increase that are two numbers that are higher. Okay, so that is the basis of our solution. And we don't need to plan for any edge cases. Like in our initial problem, we only have one solution, one potential solution. There's only one potential solution. So we don't need to plan for if there's nothing. We don't need to return undefined or anything. My plan makes sense so far to me. So I'm going to move ahead with actually executing and coding this problem. If you have any questions about this, something doesn't make sense, feel free to drop it in the chat. Once I get to the end of executing this set of instructions, then I can answer those questions. Okay, so we're going to start off by creating our pointers. So our left pointer and our right pointer. So length of, is it nums? No, it's numbers in this one. -1. We'll have our while loop to house our two-pointer solution. And we're going to make our current sum. And this is going to be equal to numbers at left plus numbers at right. And if our target is equal to our current sum, we're going to return left +1 and right +1. Okay, and then our elif statement. So this is if our target is greater than our current sum. We're going to increment our left pointer up 1. And then otherwise, this is if our target is going to be less than our current sum. We're going to want to decrement our right pointer down, but because of how this is structured, we don't need to actually explicitly write that out. It's just our assumed else statement. All right, let's test this to see if it's working with our base test cases. All right, that is accepted. Let's see if it passes the overall cases. All right, so it's beating just a little bit for our runtime, beating about 13.82%. And then for our memory, it is beating 70.76%. So that's pretty good, I would say. For memory, at least, runtime, there's definitely a more optimal solution, but I did want to show y'all a two-pointer solution. All right, do we have any questions? What do they mean by one indexed array? So this essentially means that the the first index is going to be 1 instead of 0. So a 0 indexed array is typically a default where the first index in an array string, etc., starts at 0. In this particular one, they wanted to start at 1, likely, so you're actually reading and comprehending and asking questions about the problem, kind of as a got you question, at least in my interpretation of this problem, because they also had something listed out as a problem in non-decreasing order. So they really wanted to make sure that you were reading and comprehending everything. If they wanted to reference a one-dimensional array, it would be a 1D array. So I'll put this up on my screen so you're able to see how this looks in like when it's like written out. So here, just a brief little explanation. We'll have a 1D versus 2D for like the dimensions of an array. So D obviously stands for dimensions in this case, and then 0 indexed and 1 indexed. I've never heard of a 2 indexed array. I would really be looking to make sure you're paying attention for that problem, but that's the difference for those two. Like those two, like verbiage for referring to arrays. So hopefully that answered your question. Some nice chatter between hackers. Love to see it. Okay. Oh, and then we have a nice addition from Dave. MATLAB is 1 indexed by default. So it is most programming languages that are 0 indexed, not all. There are a few random ones like MATLAB. I'm sure there's maybe another one. I'm not familiar with any other programming languages that are 1 indexed by default, but Python is 0 indexed by default, like a lot of other languages. But good to know. I'm learning with y'all on the stream. All right, so we have a little bit of time left, but I want to make sure that we have time for any general broad questions about what we talked about today. We went through some basic array LeetCode problems at the beginning. We talked about sliding window algorithm. We didn't get a chance to actually dive into a sliding window problem. I want to make sure we have enough time for me to properly explain all of that. So I'll start off next session in this stream series with a sliding window problem. We did talk a little bit about that, but we also spent probably an hour on our 2-pointer solutions. So that was what we did for the past 2 problems. I explained what a 2-pointer solution was. It's this what we just walked through, where you have a beginning and end pointer, and then you're saving some time complexity by searching or by comparing the 2 values to whatever case you're looking for. I'm going to go back to the slides. So we'll check this off later after the fact, but we went through contains duplicate today. I had checked it off out of order. We did valid anagram in session 1. But so far in the series, we've done contains duplicate, we've done valid anagram, we've done 2-sum, we've done valid palindrome, and we've done 2-sum 2. In the next stream, we'll be talking about the sliding window algorithm in more depth and doing a few practice problems, and then we'll move on to some searching algorithms. Kind of as a sneak preview, we will be learning about binary search in addition to maybe another search algorithm, depending on the time. I'm not sure which one I'll want to dive deep into, but tune in Wednesday at 7 p.m. Eastern. I don't know what the time conversion is for IST, but that'll all be on the Global Hack Week website, ghw.mlh.io is where you can find the Global Hack Week information. And of course, the slides will be available after the stream. I'll share with y'all the bit.ly link in this. Okay, so we went through 2-pointers. We went through sliding window as a brief explanation. It's a sneak preview of binary search, but we're going to go ahead to some resources. So I just wanted to highlight these in case any of y'all are not able to make the 3rd session of this stream on Wednesday at 7 p.m. again. So NeetCode is a really cool resource. I talked about this briefly, I think when we talked about learning and getting better at different problems. But LeetCode is a cool resource where they walk you through different LeetCode problems. They have written out resources and video walkthroughs, so whatever better suits your learning style. But they also have this really cool map that I have linked in the slides that'll be shared at the end of the stream, don't worry, where they have kind of like an easy map to walk through. Us as a group, we walked through some problems in the arrays and hashing section. We've obviously done some 2-pointers, and we'll move on to some sliding window problems later. We obviously can't cover all 150 problems in this 3-session streaming series, but this is a really great resource if you're looking to get better at data structures, either for technical interviewing to become a better engineer, or you're taking a data structures and algorithms course at university and you just need some extra practice outside of whatever your university is offering. And also, if you get stuck on a problem, I would recommend Googling whatever LeetCode problem you're working on, the title of it. So in this case, if you started on valid palindrome and you were very confused from the get-go, you had no idea where to start, just Google valid palindrome followed by LeetCode, and you'll usually find a video walkthrough of whatever problem. Sometimes he hasn't done a video walkthrough, but more often than not, there is one, and just watch that. I find it to be very helpful and good to look at that initial solution if you're totally stuck and you spend 20 minutes just kind of like banging your head against the table. So that is the first resource. The next resource I want to talk about is CodePath. This is a really cool program that is offered for current university students and recent graduates. So if you're not a student, my apologies, but this is a completely free online course on data structures and algorithms. This is called Technical Interviewing. They have one-on-one courses and more advanced courses if you're looking to get some live and consistent prep. I went through their 101 and intermediate level courses, and they were very helpful to both get that practice with the TAs and other students, but also to have that live practice, especially if you go to a university. Like my program didn't have a structured data structures and algorithms course built into our curriculum. I didn't major in computer science. So having that as an alternative was super valuable when I was in university and beginning to learn all of this. And then also what I have linked here is the solutions. So this is the GitHub repository where I have the solutions for the problems we walked through today. I'll update this after today's stream with the code we actually worked on. I had some base level solutions of like when I had previously done them already up here, but I'll update them with what we walked through today after the stream. Yeah. So those are some resources. And now time for questions. Thank you so much for tuning in today. I really appreciate the attention, the questions. I'd love to see everyone so engaged. Yeah, if you have any questions about the specific data structures we covered in the session, drop them in the chat. If you have any algorithm questions, drop them in the chat. Just something about 2-pointers not make sense to you. And how did you find the practice problems we worked on together? Do you have any questions on them? Do they make sense to you? I want to see all questions below. And also, if you hadn't before the start of the stream, make sure that you check in. So let's see. Okay, here's the check-in link for today's session. If you joined a little bit late and you didn't have it, it's right up here. Make sure you register your attendance with MLH. Makes you eligible for things like prizes and different achievements for Global Hack Week. Additionally, if you want to see the actual slides that I had up today, the bit.ly link up on the right-hand corner of the screen, bit.ly/GHW-DSA-pi-slides. That's where you can have find access to all of my code from today, as well as the slides. Everything's linked in there. I'll give y'all a few minutes to get checked in if you hadn't been checked in at the beginning of the session, and I'll look for some questions. So we have a question about the video resources. Great question. So if you're interested in the LeetCode video resources, like I had talked about, so the link that I have on here is the roadmap. But if you click on the problems, so say for contains duplicate, you got completely tripped up. I'm choosing this one because we already did it. I I guess, spoil the solutions for later problems in the series. It will have an explanation, kind of like walkthrough, but it'll also have a video, right? It's on YouTube. I don't want to start playing. But also, if you just Google the Neat Code YouTube channel, you can find it there. But it is, if you just follow kind of like that path, if you go to the solution on the Neat Code roadmap for a particular problem, you can find the videos. So that is the video resource. Okay. Awesome. I hope that y'all were able to get checked in. Crackers and cheese, love the problem selection and the stream in general. I love to hear it. I love that y'all are getting some value out of this and learning from it. That's the whole point of Global Hack Week, the whole point of Majorly Hacking to begin with. So I'm glad that you're enjoying your time here at Global Hack Week. And also, I want to note before we reach the end of our time together, make sure that you fill out the feedback form for this stream. I want to hear what you enjoyed about it, what you think could have been improved. We're always looking to become better at what we're doing here at Major League Hacking. So fill out the feedback form for Global Hack Week. I'd love to continue making these streams and Global Hack Week as a whole better for y'all. Thank you for coming, Crust Blake 25. I love to see that y'all enjoyed the session. Yeah. And I'm going to go back to my slides just so y'all can have these short links until the end. But if you want to access the slides, those are on the right. That short link, I put the short link to check in. It's on the right for each stream session. And also be sure to tune in this Wednesday at 7 p.m. Eastern for part 3, the final installment of Intro to Data Structures and Algorithms with Python, where we'll wrap up everything that we've gone through. And again, thank you to everyone who tuned in for session 2. I know we had some technical difficulties in session 1, so I'm glad that y'all were able to tune in and we made it through the entire thing with no issues. Knock on wood that that's the case for session 3 as well. All right. It doesn't look like we have any more questions. So that'll be the end of part 2. I'll see y'all on Wednesday. Thanks for tuning in and have a good rest of your Global Hack Week. Bye-bye.